So in this lesson, we're going to be looking at the equation of the straight line. So what basically the equation of the straight line does is it describes the relationship between x and y coordinates at any point on the line. So if you know the value for x at one point, you'll be able to know the value for y and vice versa. So it has this form of y equals mx plus c, and it has these four components of the x and y coordinate, the gradient m, and this point here, the y-intercept, which I call c. Sometimes people call it b, but I just refer to it as c. So I'm going to show you how you would derive this equation just from first principles. So if you have m, you know m of ab, well, that would be equal to y minus c, those are your y coordinates, all over x minus 0, and that is equal to y minus c over x, and then it's just a simple case of rearranging of y equals mx plus c. That's just the equation, and that's where it comes from. So, rather than just trying to memorize this, I'm going to try and explain it in a bit more kind of general terms that make a bit more sense, because I think this is quite an abstract way to look at it. So, a bit of intuition for the slope intercept. So, if you think, instead of thinking of y equals mx plus c, just think about being at a starting point, then a change happens, and then you're at a new location. So think, you're leaving your house, you then walk to the shops, and that's you in your new location. That's basically what this equation describes. So just to break it down a little bit further, your change is equal to your rate times your time. So that could be how fast you're walking for how long. If you're walking fast for 5 minutes, you're going to go quite far, rather than if you're only walking fast for 1 minute, you're going to go further. So that will be the difference in the change of your new location. So breaking this down again, we've got our c, which is what we're going to call our new location. We've got our m, which is our rate, and then we've got x, which is going to be time, and then we're going to have our y, which is the beginning point. Okay. I said that. No, sorry. C will be the beginning point, Y will be the new location. All right, so let's draw this out. So you've got here would be your starting point C. And what's going to happen is we're going to travel along at a rate, which is your m, for a certain amount of time. So rate m. And then you do this for so much time. That's your x. Okay, and this will give us the change of our changing point. Or the distance we've changed, how much we've moved from where we were originally. So change. And that's just m times x. And that will finally give us a finishing point here, which is y. So what we're basically saying is our y is equal to, so the end, which is y, is equal to the starting point, which is just our y-intercept. So starting point, okay, here that's c, plus the change. That we know is just x. Well, actually, I've written those the wrong way around, but it's fine. So this is what we're really trying to get. This is why this plus c point is important, because just depending on where this is will affect where we end up in the end. So I hope that kind of gives you a more kind of clearer idea of where this equation comes from, what its use, and what its use is, and so it's not just you trying to memorize all these different facts. Okay, thank you very much.